Alright, back at it again, LONCAPA 3. I can't exactly solve problems anymore, but I can set it up and show the concept, so same difference. Okay, so this one is just a bit confusing for the free body diagrams. So to set it up, you actually have to draw each one individually. So you'll draw the person and one for the chair. Okay, so the chair's free body diagram. Actually, we'll start with the person. The person's free body diagram has that tension, but since he's pulling, so he's pulling on the rope down, but the pulley changes it, so it's actually going up. So here we have, let me click off. Here we have tension goes up, and I'll actually move it down a bit so I have some space. Tension goes up, and we also have the normal force of the chair on the person that goes up, and then we have the force of gravity of the weight of the person. Then for the chair, we have tension that goes up, and downward we have the force of gravity of the chair and the normal force of the person on the chair, because this is action reaction forces, remember? So action reaction. Okay, so then you'd set it up like this. So you'd have your person, and usually I'd write in the x direction the forces, in the y direction the forces, but there's only one direction, so I'll just write it once. And you have your F net. So F net is equal to your normal force, and remember, since the normal force of the chair on the person on the chair is the same magnitude, so I'll just call it the normal force from now on, so they're both just the normal force. So normal force plus tension minus force of gravity of the person. So the mass of the person times gravity equals the mass of the person times acceleration. Then we have the chair, and the chair here is force equals our tension, so tension going up, minus our normal force minus the mass of the chair times gravity is the mass of the chair times acceleration. Okay, and remember, we have a lot of these values, so I'll highlight the ones we have. I think we have, so we have both of these, both of these, both of those, both of those. So what do we really have? We have two unknowns, two equations. Okay, so from here all you have to do is rearrange. So rearrange, and because we're trying to find tension here, we'd rearrange to find what n is equal to, so that it saves us time, so our n's just end up canceling out. The other way to think of it, if you can use this way and you're fine, and you can just leave the video, but the other way to think of it is that both masses, so it's one system, so mass of the person plus mass of the chair, but this time the tension is attached to both the chair and the person's pulling it. So tension up is actually 2 times tension, and down we just have Fg of the mass of the person, so Fg of the person plus the chair. So that's another way to think of it. Alright, good luck.